So we're gonna finish 2-7 today. I'm not gonna go super fast, but we've got a lot of word problems. I'll tell you kind of what I think are the most important, and we'll just kind of work through what we got here. 2.7. We can do number 9 on 2.8. That would be awesome, but I'm not gonna sweat it if we don't. So we did all of number 6 last class, am I correct? Okay, perfect. So those are important problems. Those are what we call work problems. They are word problems because there are words involved, but they're the ones that are like alone together, alone together. Let me just review that really quick. So these work problems, you're doing something, you're painting, you're filling a drain, you're doing some kind of work, and it will tell you one person or one thing can do it this fast, one person or one thing can do it that fast. And then it will either ask you how long will it take you to do it together, or in the case of like the number 6, it was asking us about the drain. It was like, how long does it take to drain the pool if we know both hoses are going and the drain is open and it takes us long to fill it up? So we kind of had a bigger equation to fill. This is not necessarily a proportion, so don't think of it like 5 over something equals X over something else. They're separate fractions. So on the first one, I had Jessica was painting, so it takes her 5 hours to paint her room. I represent that as 1 over 5. Same thing, Brenda takes 6 hours to paint a room, so that's 1 over 6. And we don't know how long it takes them to do it together. We call that 1 over X. I don't know if I have room for this on the quiz, but this is definitely on your test when we get to the test time. These other problems, some of them are not as important. I believe the last one that we do, number 10, will be definitely important. So we'll make sure to talk about that. The rest are semi-simple, but can be kind of irritating. So we're just going to go through them one at a time as fast or slow as we need to. So we're on number 7 now, and it's talking about selling golf hats. It says, this Midtown Sports Apparel Inc. has found that it needs to sell golf hats for $275 each in order to be competitive. It costs $212 to produce each hat, and it has a weekly overhead of $3,000. So numbers I see, we currently are selling for $275. It costs us $212 to make a hat, and to make all of the hats, our weekly overhead cost is $3,000. So letter A says, let X be the number of hats produced each week. Express the average cost, including overhead, of producing one hat as a function of X. So we're going to call this F of X. And how much does it cost to make one hat? I didn't say how much does it work for one hat? 212. Good. So we're going to say that's 212 times X. And then in order to just like run our factory, it costs how much? 3,000. Very good. We'll say plus 3,000. Now it doesn't say that's how much it is to make all of the hats, but it says I want to know how much is it to make one hat. So we're going to take this number and we're going to divide it by X. So this is the cost per hat, and this is how much it is for the overheads for all of the hats. So 30 or 3,000. So we're going to add those up and divide by X, just exactly one hat. So this is the ability to find one cost of one hat. Okay. Letter B says, solve algebraically to find the number of golf hats that must be sold each week to make a profit. So we need to match this price, and we need to go higher than it. So we already know we're selling the hats for how much? $275. So I'm going to set it equal to $275. So the amount that it costs for each hat, Max. All right. You're okay. The amount that it costs for each hat is $275. So I'm setting that equal to the expression we just wrote on how much it is to produce each hat. What we're about to find, X, is going to be the number of hats that we need to make in order to like break even. How many hats do we need to make and sell at $275 to like get equal number, a $0 profit? And then we'll say we need to sell more than that. This looks like a scary equation, but if we just multiply by X on both sides, we end up getting a pretty simple algebra 1 equation. 275x equals 212x plus 3,000. This is pretty simple, minus 212x from both sides. I think I get 0.63x equals 3,000, and then x is going to equal calculator 3,000 divided by 0.63. Okay. Should I round up or should I round down? So if we rounded down, that would be below profit, right? We should round up on this one. It's not like we've done examples with like animals, and it's like we can't round up an animal, so we got to round that down. But when we're talking about these hats and we want to make a profit, we have to sell this or more. So I'm going to round it up to 4,762 hats. That's what we need to sell. Now that's just to make any kind of profit. That's to just not make zero, to make just a little bit more than what we're spending on the hats. Letter C says, how many golf hats must be sold to make a profit of $1,000 in 1 week? So this expression is my weekly expense anyway. So how do I show that I want $1,000 of profit here? I have an idea on where I put that $1,000. Add it to the 3,000. So we take it into consideration. 3,000 is how much we have to spend to like keep our building or whatever. We're going to add 1,000 in that to make it a profit. So we're going to call that 4,000. Guess I'm going to do it over here. I'm going to do the exact same equation. So letter C is going to be 275x equals 212x plus 4,000. So that's pretty 4 over x. So work its way on this. Is you all done? All right, so we should be solving this. I get 275x equals 212x plus 4,000 minus that 212. I get 0.63x equals 4,000. And then I divide 4,000 divided by 0.63. And again, I am going to round up. So I'm going to round that to 6,350 hats. This whole problem, this whole unit is about kind of these reciprocal functions, these rational functions, which makes sense that our equations have an x in the denominator to represent that reciprocal function. All right, next problem. This one's a little bit simpler. We got a little bit of plug and chug. Does anybody have any questions so far? Everybody's singing in there. This one's talking about a bear population. It says the number of bears at any time t in years in a federal game reserve is given by this equation right here. T equals 500 plus 250t over 10 plus 0.5t. Find the population of bears when the value of t is 10, 40, and 100. How do we do that? Just plug it in for what? Just plug it in for t. So let's work smarter, not harder. So boys, can you plug in 10? Can you do p of 10 and figure out what that is? Girls, you do p of 40, figure out what that is, and I'll do p of 100. My alpha had a hard time plugging in, and I think maybe we're just tired, but make sure that you can plug in and find the right answer because we're gonna have issues. All right, I found my number. Take a second, make sure you find your number. Boys, you're plugging in 10, girls, you're plugging in 40. All right, boys, what did you guys get? Brian? 200. I think that is good. Girls, what did you get? I didn't get 333. 350. Yeah, double check. Just I bet there's one thing that was off. 350. Yeah, I got that. Good. Okay, perfect. Okay, so we plugged in, those are the values. If after 10 years, we should have 200 bears, after 40 years, we should have 350, after 100, we should have 425. And then letter B says, does the graph of the bear population have a horizontal asymptote? If so, what is it? If not, why not? Remember, I just said that we are in our reciprocal graph, our rational graph part. If this is a reciprocal graph, what would I look at to decide my horizontal asymptote? What would I look at? I think I know what you're talking about. Zach, what were you gonna say?
Use the 215.
Yeah, so we look at I would say we look at the variables, and if the variables have the same exponent, then that's the word, variables. And then we look at their coefficients. So since it's t over t, then we just make a fraction of the coefficient. So I would say, yes, there is a horizontal asymptote. Yes, and it's at 250 divided by 1/2 by 0.5, which I'm actually going to do that in the calculator. 250 divided by 0.5 is actually 500. So we have a horizontal asymptote at 500. That means we're going to have a stopping point there. Yeah, not too bad, right? And if I maybe forgot that, I might have reminded myself, I might say in a reciprocal function or in a rational function. Look at variables and exponents to find my horizontal asymptote. I'd write myself a note if that was hard for me. All right, once you're done with that one, go ahead and flip your page. Let's look at number 9. Let me save you. So I have that for the later. Okay. This next one kind of looks like the work problem where I had 1 over alone plus 1 over alone equals 1 over together. That's basically what we see here with the R's. It's talking about resistance. I'm gonna be honest with you, I'm not a big like physics person or science chemistry person, but we got to do some of these little examples like this. Total electrical resistance R of 2 resistors connected in parallel with resistance R1 and R2 is given by that. Okay, so we need to write an equation. We need to express the total resistance as a function of X, knowing that one of the resistors has a resistance of 2.3, and we don't know what the other one is. All that means is we're just going to plug in. We don't know what the total is. We just know one of the resistors has a 2.3. So I'm going to plug that in for R1. Instead of R1, I'm going to write 2.3. And instead of R2, I'm going to write X. And write X. Okay. It says it wants the total resistance R as a function of X. That means I want R all by itself on one side of the equation. So we got to simplify this enough to get R all by itself. We're doing this in the same unit that we're clearing out the denominator. So what would I multiply to clear out my denominator here? And one more thing in the denominator, right? R. We got to do multiply by 2.3 and by X and by R. So in the first one, the R is going to cancel with the R, so I just get 2.3X. Don't forget to bring your equal sign with us. And the next one, the 2.3 cancel and I get R times X. Then I've got my plus sign and then the X cancels and I get 2.3 R. All right, we got to get R by itself. Does anyone have any ideas on what I can do to start getting R alone? Factor. Let's factor that R out of everything. I get 2.3x equals R x plus 2.3. And now I want to get R alone. I'm almost there. What do I need to do to just get R by itself? Ava, divide x plus 2.3. So I'm going to say R equals 2.3x over x plus 2.3. Cool. All right, so that's my answer for letter A. Letter B says find the resistance of the second resistor if the total resistance of the pair is 1.7. Where do I put that 1.7? Does it go for my X or for my R? Goes for my R, which is a bummer. It's not as easy as if it was my X, but that's okay. I believe we're still going to be all right. We can solve it. So I'm going to do 1.7 equals 2.3x over x plus 2.3. And I know this can look big and scary, but if you think of this as 1.7 over 1, we're just going to cross multiply and we're going to solve that way. So I get 1 times 2.3x, so just 2.3x, and then 1.7 times x plus 2.3. And I'll distribute that 1.7 to both of those. I personally like to do those in 2 steps. You're welcome to do it in 1 step, but I like to do it in 2 just in case. So I get 1.7x plus 1.7 times 2.3. So I get 3.91 minus that 1.7x from both sides. Six equals 0.6x equals 3.91, then 3.91 divided by 0.6. So x equals 6.52. We're going to get into number 10, which again, I think is one of the more important ones. The last couple we did are not as important. The next one is a little bit more important. I do need a calculator on that. Let's make sure your calculator is out. Okay, so this one is talking about minimizing perimeter. We've done one, I think, similar to this. It says, consider all rectangles with an area of 182. And it says, let x be the length of one side of such rectangle. So I'm going to draw a rectangle. I don't know exactly what it looks like. I don't know really what its lengths are, but I know it's a rectangle and I know its area is 182 feet squared. We know one of my sides is x. And if we remember, area of a rectangle is just length times width. You can make your other side W or you can make it Y. I don't know how the two sides relate to each other, so I can't make it like 3x or 2x plus 5 or something like that. It's just got to be a totally different variable. I'm not sure how they relate. So I'm going to make it a Y. Let's see. Okay. Now, if we are thinking about this, I've got enough information to kind of set up an equation in terms of area. So area is 182, and that's just going to equal x times y. I'm going to need that in a minute because they haven't even asked anything about area. Everything they're talking about is perimeter, right? So you're like, that feels like a waste of time. I promise it's not. But that being said, we got to deal with perimeter. How would I represent perimeter of this shape? right? Good, 2x plus 2y. There's a lot of different ways you can write it. You can say x plus y plus y. That seems kind of silly and redundant. You can do 2 times x plus y. There's just a couple of different ways. So this is fine this way, 2x plus 2y. Okay, now the reason I made us do the area first is because we're gonna simplify the area formula either in terms of x or y, and we're gonna plug it into the perimeter. Right here. Yeah, like that. So let's take the area formula and let's actually get y by itself. That way I have an equation with all x's, because that's what we're trying to find. We're trying to find x, so I want an equation with all x's. So if I get y by itself, I would have had to do what to both sides? How do I get y by itself? Let's divide by x. So that's 182 over x. So I'm going to plug that in for my y here. To get a little bit more space. So let me spread it out. Perimeter is still 2x plus 2y, but instead of writing y, we can replace that with 182 over x. I don't really even need, I've got all this new space. I'm not even going to do anything much algebraic. All I'm going to do is take this equation. The problem said we want to minimize the perimeter. The letter B says find the dimension of the rectangle that has the least perimeter, which means it's the smallest perimeter. We can just go graph this and find the minimum. So I'm going to graph and find minimum. You are welcome to like multiply out and try and solve algebraically, but I don't technically need to do that. If only if that makes you happy, do it. If not, it doesn't make any difference to me because I can plug that into my calculator regardless. I have nothing it's equal to, which is fine because I'm not trying to find any intersections. I'm trying to actually find the minimum. So once I put it in my calculator, it's 2x plus 2 times 182 divided by x. I may need to play with my window. We can even go to a normal window because that's probably what yours is in, right? If you're in a 10, negative 10 to positive 10, I don't see anything. Do you? No, that's probably a little alarming. Let's go. Let's make my mins can be 0. I don't need any negative numbers. That doesn't matter to me. Let's see. Let's make my x max. I don't know. I make it like 50 or 100. I'm maybe going to go a little bigger because I'm not really sure what my graph's going to look like. So I'm going to guess 100. And then my y max, I was talking about 182. So I'm probably going to make it like 300 or 500. We'll kind of see where we're at there. 300 works. Oh, nice. Okay. I see a pretty clear graph here. And I actually like this window better than the one I made my alpha because I think that you can see where the minimum is a little bit better. We're going to do second trace minimum. And I want you to just, you may think you know where it is. I'd go a little bit wider than what you think it is. So I'm going to go my left bound like really high up over here. If I can get past that little, yeah. I'm going to go really high up over here. I'm going to press enter. And then my right bound, I'm going to go when I know that I'm starting to increase again. I'm going to make kind of a wide window. My minimum is here at 13.49, which is about 13.5. So that point is 13.5 comma 54. Yeah, good. What does that 54 number symbolize? Anyone know? That's my y. And what's my y in this problem? Not the length. If this was the equation that I plugged in, what's my y? Would you say that, Brian? The perimeter. The y is the p, the perimeter. And then my x is what? What did my x represent in this problem? This side, good, it's one of my sides. So I can go back over to my picture. I know that my X side is actually 13.5. Do you know how I find what my Y side is? Good, where do you want to plug in X to, Gavin? We could plug it in there, but I don't really know what that, I guess I could use a perimeter of 54. I think an even easier one is to plug it back into this equation right here. So I just have two variables there. I have Y equals 182 over X, and I'm actually in a really nice place to just go, what's 182 divided by 13.5? And I get about 13.5. Now, I probably see the trends a little bit more than you guys have, because you've probably only done like 1 or 2 or 3 of these. I've done like a lot in my however many years of teaching this. I'm going to tell you a lot of times this is a square. A lot of times it's the exact same change, whether we're doing a maximum or a minimum. In order for it to be max or min, it's oftentimes a square. So if you get the same number, don't be alarmed. That's probably the right answer. I will not put a question like this on your quiz, but I would be planned for it for your test. Okay. The only word problem I would probably do for your quiz is one of these work problems. Other than that, there's a lot of other things I need to make sure you know, whether it's the graphing of the asymptotes or the clearing denominators. There's other skills. So I'm not doing a lot of these word problems, but I needed to make sure we got them. Now this is where we're done with 2.7. So that 2.7 homework is due tomorrow when I see you. That being said, we still have a few more minutes of class, and I need to get through at least number 9 on 2.8. If not, if we can do number 10, awesome. If not, I'm not that stressed about it. 2.8 isn't too hard, it's not too crazy, but this is a very different skill. And since we're kind of in our solving word problem skill right now, let's just kind of keep on that mindset, okay? So we're gonna scroll all the way down to the very end of our notes. We're gonna go to number 9. And I actually believe you've done number 9 before. Let's read it. It says Dixie Packaging Company has contracted another firm to design boxes with a volume of at least 600 inches cubed. Squares are still to be cut from the corner of a 20-inch by 25-inch piece of cardboard with flaps folded up to make an open box. What size square should be cut out from the cardboard? So if I were to draw this, we've got a 20 by 25 piece of cardboard. And we're cutting squares out of each corner. Does this look familiar to you? Hey, we've seen this problem before. My squares are not super to scale, but that's all right. Just be nice to me. You all done? Right there. All right. All right, this looks familiar to us, right? Let's label those sides as 20 and 25. And what should I label the X's at? Or I just read that, didn't I? Yeah. I like think in my head like that. I like I'm trying to like softball, pass your little question, and then I just ruin it in my head. So we should label the squares as X's, right? I ruined that. But I won't ruin this. What are my new sides now? If we cut those X's off, what will this side be labeled as? Say again, Ava.
20 minus 2x.
20 minus 2x. What about this side?
5 minus 2x.
Good. And you guys remember that that's true for any problem that we do with this. Whatever the side lengths are, you do that number minus 2x. Because I'm cutting off an x from not just one side, but both sides. So we're going to minus 2x from both of those. Okay. Now, we got to remember, see if we remember how to do the volume. Remember, volume is just length times width times height. How would I write the equation of this volume?
Equals 5 minus 2x. 20 times 2x, and then. Would it just be x?
But is my height just X? Yes, no, maybe. That's what we fold up, right? So if this is like the amount that we're cutting up, that's what we're gonna fold up. So yeah, height is just X. And I like to put my X out front. It doesn't truly matter where you put him, it's all multiplying. So it's commutative property, he can go anywhere. I just personally like him to go out front. X times 25 minus 2x times 20 minus 2x. Okay, now it says that it wants the volume to be at least 600. I'm gonna write 600 as my volume. Actually, I'm just gonna erase this V over here and write 600. Am I gonna use an equal sign or am I gonna use an inequality? What am I thinking of? Yeah, which one?
Like, it's greater than 6, but for equal to, this has to be at least.
This one?
Yes.
I don't know. Let me think of this. I want at least 600, so I want more than 600, right? So, okay. Sometimes inequality gets me mixed up too, so I wanted to think that through before I told you yes or no. So yeah, I want the 600 to be smaller, I want the other number to be bigger. That's not super important for me, it's just gonna help me when I graph. It's gonna be like some kind of upside down parabola, and 600 is gonna be like about here. And I want everything from one end to the other in the middle. I want all of these numbers. Now, before I go graph it, let's talk about our domain. Because our range is a little funny, it's always gonna be a pretty big number, but I want our domain, our x's, to be really specific. Do you remember what the smallest amount I can cut off of each corner is? 0. I can cut 0 off of each corner. Now, in this case, what's the most I can cut off of each side? Based on these sides, what's the biggest amount I can cut off of both sides? More than 5. 10. Why did 10, Isaac? 20 divided by 2. Why did you not do 25 divided by 2?
No, I kind of just remember from the shorter side.
Sure, yep. It just makes sense because if I get more, half of 25 would not be an equal amount I could cut off on each side of the 20. So I have to cut the same amount. If I cut off like 12 on one side, I don't have 12 inches to cut off on the other side. So I need to make sure it's right down the middle. So it's going to be 10, which is half of the smallest side. Smallest side divided by 2, which in this case, it's going to be 20 divided by 2. So our x min and our x max is going to be 0 and 10. Our y max has to be bigger than 600. I'm probably going to guess 1,000 or 2,000 so that we see enough. And I'm going to go put these in for my, one of them is going to be y1. So I'll make x times 20 minus 2x times 25. Minus 2x. X times 20 minus 2x times 25 minus 2x, and then 600 is going to be my other one. Window, x max is just 100, and y max, make it 1,000. I'll see if I can see in there. If not, I'll make it bigger. Oh no, that's perfect. Went up to 1,000. You remember how to find the interval of the answers that we want? Second trace, so let's bring in some bells, or you're already doing it. Intersect, you find both intersects. Whether it's first curve, second curve, or left bound, right bound. The first one is at 1.66 or 1.7, I guess I'll round to the 10th. And then second trace for the second one, intersect, left bound, right bound, 6.2. Can we include 1.7 and 6.2? We want at least 600. If you want at least an 80 on your test, can you get an 80? Yeah, okay, so I'm good with that. So we'll do bracket 1.7 and then 6.2 bracket. And that's the interval at which it works. Alright, I'm good with that progress today. We have one day to do 2.8. We are gonna do a quiz on Thursday on what we've done in 2.6 and 2.7. And then any 2.8 we need to finish, we'll finish on Thursday as well. I'll have a review sheet for you on Thursday too. And again, let's try and get caught up this week. So if anybody's missing a test, make sure that we get that done this week. I'll turn this guy off.